All right. Thanks, Colleen. My name is Ryan Case. I'm engineering director at Memfault. And I'd like to talk to you today about the virtuous cycle for shipping Android devices, monitoring, debugging, and updating. And specifically, the tools needed to do that. You can build this. You may have already used tools for this, or built tools for this, or looking for tools to do this. So I'd like to give you an overview of some of the tools we see others using in this, others are using in this space. And I hope that can be a useful starting place for you. This is going to be a little bit broad. It's our first Android webinar, so let us know where you'd like to see more elaboration and what you'd like to see next. So Memfault provides an observability and fleet management platform, and I worked on this system for Android with the Memfault team because I'm convinced from my experience that good tools are the key to staying competitive. And I find it really motivating to see the companies that we work with develop products faster, get to market faster, and have higher quality products. So Memfault is a global company with offices in San Francisco, Boston, and Berlin. So we're hiring all over the globe. I just wanted to throw that out there. Check out our website to apply. So, all right, on to the good stuff. So we talk to a lot of companies, and they all have very different tools that they're using, but there are some that are kind of the prototypical tools. So in an homage to Monty Python, let's call this typical company the very big corporation of America. And that can guide us in what we cover today, because after all, it is a very broad topic. And this is pretty subjective with what we include. So these are the typical companies that we're seeing and the tools that they're using. And this might be a familiar story to you. So, very big corporation of America has an issue. They get a bunch of customer requests coming in, and they want to debug it. They reach for the typical tools, logs that they've collected, maybe crash reports that have been sent in. The team gets to work, they try to figure it out. They think they've fixed it. They send it a speculative fix to a subset of devices. This is sounding familiar. And then they use monitoring tools like dashboards to see if things got better or worse. So today we're going to take a look at what sort of tools companies are using to implement this sort of flow. So we'll go through each step in this virtuous cycle, starting with, like we said, debugging, and then updating, monitoring. And for each step in this process, we're going to think about the data pipeline that's involved, starting with Android. These are the Android APIs that we're all familiar with. Thinking about an agent that we will need to put on the device to exercise those APIs. So by agent, I just mean some kind of on-device software. That could be an app or a system service or something like this. There's going to be the backend code. This is very broad, but we're talking about databases, processing, things like that. And then, of course, this wouldn't be an enterprise webinar if I didn't say the word dashboard. So we've got dashboards in there. And in the case of debugging and monitoring, the data is generally flowing in one direction from the OS down in the sense of this slide to our dashboards. In the case of updating, things are generally going the other way, right? The user or yourself are interacting with a dashboard, determining the rules of what devices will get what payload, and then that payload will get propagated down to the OS, get downloaded by the devices, and then installed using the OS APIs, as we'll dig into. So how are we actually going to present all of this? Let's walk through an example. So in the case of debugging, let's evaluate quickly the landscape. So we'll go into more detail here. I just want to make sure these tables are comprehensible. So with debugging, like we said, a technology that we see very often is logging. So we're all familiar with logcat, or the logging daemon logd. So that's something that's inside AOSP. And we're going to for each technology that we look at, we're going to see, which pieces of this pipeline it will fill for us, and we're going to give a score. And score is a value out of 3 and an effort out of 3. So in the case of Logcat, I would say that very high value, and we'll explain why, and very, very minimal effort. We're going to give a color as well. So green, this is sort of a solved problem, getting logs on Android. Again, logging is a very big topic. This is very subjective, but I think in general, we'd agree that, for the purposes of debugging, Logcat and the information inside logd is quite good, at least for the purposes of a very big corporation of America. And then we're going to look at other technologies that are going to help us fill in this matrix. Are there backend tools we can use like cloud storage? We'll give those a score as well. And we'll see what's missing. And again, this is representing what we see with the companies that we talk to and what we see in this space. So in the case of things that are a good fit and a solved problem, the squares will be in green. And in the case of things that are missing, they'll be in red. This wouldn't be an analysis without some assumptions. So let's start there. So, just to frame it, again, big corporation of America, you might not be a big corporation, you might not be in America, but hopefully this still applies to you, even if you're a smaller company. So typically, companies might have hundreds of thousands of remote devices that are geolocated all over the world. So that means, we're not going to be able to open a drawer, pull an Android device out of our desk, get an ADB connection, and grab some files off of it. This is going to all be done remotely. We're preferring build over buy. So that means we're looking for tools that are open source, they're free, or at least they're cheap. And speaking of budget, we assume that we have a small engineering team that can help us build and maintain this this set of tools that we're going to put together. And we also have a small budget for hosting costs. After all, this is pretty critical infrastructure, so we have to have a budget in place for that. And again, we'll also make some assumptions about the methods for this domain. So for debugging, we'll assume we're looking at logs and crashes. That's typically what we see people collecting. For updating, we'll talk about OS updates. And for monitoring, we'll talk about metrics, and we'll talk about what we mean by all of these terms as we go through each of them. So logs, pretty straightforward. These are just a record of what happened, usually a timestamp, some metadata, and a record of an event. So logs in Android Studio, I think something that's probably burned into our minds. To anybody who's done Android development, they've tailed logs over ADB. This is logs coming from a single device, usually a single process or package. There's some filtering there, so we can observe what's happening. But what about these this big corporation of America with devices all over the place? How are they going to do this remotely at scale? What about things like privacy? All these other considerations. This is not just a matter of grabbing logs directly over ADB from a device that's sitting on our desk. So let's dive into it. The first thing that I tend to see the most often is companies using bug reports. And maybe this is a little controversial, but I would give that a neutral score, because even though bug reports can contain so much data, they're a big zip file produced by this native application that's been in Android since the dawn of time called dump state. It produces these huge snapshots of what's going on in the device, and that can be really useful for debugging. But for this particular purpose, we want to call out a few things. Like, these are production devices that we're looking to monitor, and for that reason, we have to be mindful of performance. And in some cases, dump state will, if the device is in a certain state, it can actually trigger forking every single process on the device. So there can be a big performance impact Also, performance impacts in terms of bandwidth and storage, because you're gonna have these large files queued up on the device. You've got to send them off the device. Sometimes that's meaningful, and we also have a lot more processing to do, because there's a lot more data. And finally, it's really bad from a privacy perspective because, especially in the case of the device having personally identifiable information, PII, we just get this big ball of data, and it's much harder to scrub. So things that we really want to be mindful of in a bug report are things like user location. Often the last known location of the device will be in there, the list of apps and all kinds of other sensitive things. So we want to be really, really careful about that. So dump state itself will grab logs from logd, like what we talked about in the example. And I would say that that is a better solution, and something I think is going to be a better fit for us as we build our tools. And the reason is, it just gives us a lot. It gives us a lot of the same benefits without that same sort of performance and privacy constraints or concerns. So there are a lot of different log buffers on Android. There's the event log, crash log, radio logs. They're separate. You can change the size of individual buffers. They're not persistent by default. So if you reset the device, that means you'll be losing those logs, which can be a problem for debugging certain kinds of issues. You can change that by setting a system property, but just something to be mindful of. The reason that it's off by default is because there's a lot of logging on Android, and that can obviously increase the wear on your flash peripherals. So just be careful of that. One other thing I'll just call out, not to talk too much about logd, but because it is such an important piece of the puzzle. Kernel logs were previously, we'd capture those prior to Android 9 through dmessage. And the kernel logs are super important for these low-level issues that might be happening on the device. The problem with dmessage is that the timestamps were in a different format, and that would often make kernel issues difficult to debug, particularly when there is some kind of interaction between the kernel and other parts of the system. So starting in Android 9, or if you're on a previous version of Android and you can backport the patch, things are much easier because you don't have to do that sort of timestamp processing. That is something that Memfault does offer if you're on an older version of Android, but oftentimes that piece of information that you need to correlate the timestamps is not always there. All right. So dump state and logd are going to give us the data that we need, but we have to get it off the device. So we have to implement an agent. That's not there, so that's why it's in red. So periodically, or after some kind of an event, we're going to want to collect logs. For example, we'll see exercise devices. We'll collect a log of what happened after a workout, devices that are used for exercise, because if the user reports an issue, then the developers or the engineering team can go in, or customer success team can go in and understand what exactly happened. So that's a sort of activity-based event. Another type of event that might be useful is on an error. So one API that we might be interested in is the rescue party system, because that kicks in when the device is in a crash loop. So that might be a time where we want to capture some logs. Once we get the logs, we still have a bunch of things we got to sort out. We got to upload them. We have to spool them. Manage them inside of our agent. We also might have to do a bunch of remote configurations. So these are production devices. So in some cases, you might not want to have a high level of verbosity. Maybe depending on geolocation, there might be certain degrees of compliance, user opt-in, terms of service, things like this, versioning, all these sort of considerations. So just calling it out that it sounds like an easy thing, just like call an API and throw up some files, but there's actually quite a bit to it. But it's all stuff that we can do. Just these are gaps that we have to fill in. And finally, we mentioned privacy. If the device does contain personally identifiable information, we may need to implement log scrubbing, because of course it's going to be best if that sensitive information never leaves the device at all. Cloud storage. I remember when I first got started at a smartwatch company called Pebble. This is where, this was the complexity of our initial system, was grabbing some logs from the device and throwing them into an S3 bucket. And I'd say that's an easy win. Kind of unlimited file storage, very straightforward, but we don't really get anything else, unfortunately. So as a result, we're going to have to build the other tools. Like I mentioned, if you get demessaged logs, we're going to have to do processing on that. If we have scrubbing, we might have to do, if we have a sensitive information, we might also have to do scrubbing there on the server side as well. And, I think it's sort of debatable, whether or not you want to implement in a sort of simple system some front end. I think it's pretty straightforward just to set up a small React app or something like that and be able to view a log file in the browser. There are much more complex solutions that I really debated putting in here, but I don't want to spend too much time on logging. But if you're really interested in this topic, there's some great DevOps tools like what's called the Elk Stack, or another one called Graylog. These are cloud-based log monitoring solutions. And there are a bunch of challenges, I think, if you are consuming data not from a set of servers, but rather from IoT devices. But yeah, I just want to call that out there. That was an intentional omission. But I also have never seen a, a company of this profile implement something like that. Okay, so that was kind of the landscape slide of logging, what's out there. I'll just say Memfault solves all of this for you. So if you're getting a little overwhelmed, no sweat. So imagine you're at your desk, you see your devices all around the world in Memfault, and you can easily pull up a single device. You get a timeline with all the crashes and metrics and log files all visualized together. You can drill in, quickly get context from logs around crashes that have happened. And then of course, regular expressions, filtering, things like that. You can even adjust the time of the log, the time zone of the log to be your time zone or the device's time zone, things like, small little things like that we find really streamline the development process. So you could build it, and that's how we see companies doing it, but Memfault also solves it for you. All right. Second kind of debugging that we commonly see are crashes. And again, this probably looks pretty familiar, little same log viewer in Android Studio. So here we can see a program stopped executing. We can see the stack trace that led to the crash. And in the case of crashes, we'll start with bug reports again, because that's frankly the tool that we see the most commonly used for collecting crashes. And bug reports, I would say are actually not a good fit. Just my opinion. It might be a little controversial because of those same things that we talked about before, the performance and privacy and processing issues, in addition to some deduplication issues. So we're actually, making our lives a little hard when we collect bug reports and extract crashes, because there's going to be crash files in there, and we're going to have to figure out if we've seen them before or not. There's actually a much easier API to use called the Dropbox Manager. The Dropbox Manager broadcasts different blobs of logs, and in practice, it's very useful for getting crashes. So the types of crashes that we can get are things like tombstones, which are records, like files of native crashes. ANRs, those are application not responding errors. Those are in files as well. Java exceptions, all kinds of different crashes. What are not there? Actually, one other thing that's in broadcast by the Dropbox Manager are the kernel logs from the last boot. That's called the last K message. So that's very useful if the device, say you're booting up and the device notices that there was a dangerous reboot. it's great to be able to get that last K-message log. But what's missing, the Dropbox manager does not broadcast kernel oops, which are very important. Also doesn't broadcast SE Linux violations. So those are something that you'd have to pull out of audit D logs. So there are some gaps that we're going to have to fill in here. And then the other technology that I think is worth checking out that we're all very familiar with, and I think everybody seems to use, is just like a general cloud APM solution for monitoring crashes, something like Sentry, just as an example of one that we see companies using very commonly. So in this case, they will provide an on-device SDK. It's not really wired up in the way that we need it. It's more, catered towards application crashes. So we're going to have to do all the wiring up. We can maybe use the uploader though. And maybe one of the only things, in addition to the same sort of spooling, remote configuration, things that we already talked about, the one thing that we'll have to add is rate limiting. In the case of the device crash looping, depending on how your devices are configured, you don't want to be sending an incredible amount of data and really throttling device performance and things like that. So that's worth implementing. And in the back end, we can just take advantage of the cloud APM, except that we're going to have to, this is going to be a common theme, handle a lot of the processing. So we get these raw files and, say take a tombstone, for example. First of all, we got to extract the backtrace. Second of all, it's just going to be a bunch of memory addresses. That's not particularly helpful. So what we're going to have to do is take symbol files from our OS build and smash them together so we can get an actual symbolicated backtrace. And when you have a tombstone, you have something called a GNU build ID in there. So you got to pull that out and take a look at the symbol files and do all the wrangling. So there's a lot of basically implementing that kind of service can be tedious and but very important in order to make any use of these files. There's quite a bit of processing that might need to happen as well. In addition, we talked about parsing out those kernel oops, those SE Linux violations, if you are interested in those. And then if you happen to be obfuscating any of your apps, you'll want to also deobfuscate those. So same sort of process. But we do get some great tools in the front end from some great dashboarding tools. So that's great. So in Memfault, we will solve all of those problems of processing, building an agent, things like this. So you can sit at your desk, take a look at your fleet and see issue filtering by component and package. In some cases, we have app developers who save searches for crashes coming in just from their specific package, or a system engineer will filter just for kernel oops. You can dive into an ANR like here, see the backtrace, quickly pull up the logs. So it's nice to have it all in one. Okay, system updates. So, big corporation of America has had this issue. They've debugged it using logs and crash data. And they whipped up a fix. Now they need to do an over-the-air update of their devices. And yes, you could roll your own OTA solution. It is possible, and we'll talk about how to do that. So Hawkbit is an example of an open source web framework for doing device updates. That can be very handy here. This is a screenshot of their device management dashboard. So as before, let's start with the on-device APIs. So we have a win there. The recovery system and update engine APIs are great. They just pass over our payload. They handle all the cryptographic verification. In the case of the update engine API, they also do A/B updates. This is if your BSP supports A/B updates, and that's really great if it does, because it means that you're able to have two different versions of the OS on the device at a time. So you'll have the one that's currently running, the new one that's downloaded, the device will reset, try to boot into the new one. If there's an issue, it'll fall back. into the other slot that is a known good, and that's great. The last thing we want to do is brick devices, so that's definitely worth using if you have it available. One area again where we're going to lose is in implementing an agent. So we're going to have to think about the UX of the install process. Do we want that headless, or do we want a UX flow? We're going to have to think about whether or not we want metrics collection to monitor the quality of service of our CDN that we'll talk about in a second. So we'll need things like this, maybe other features like resumable downloads to implement, just a variety of things. And in addition, we'll have to implement some kind of client that can talk to our backend to tell it what version it is and what its configuration is, so to support the rules engine in the backend. So we said low cost, but unfortunately, I don't know if there's really any way to get around using a CDN with payloads like Android images. They're just very, very large, hundreds of megabytes or gigabyte. One way we can make our lives a little bit easier is by using incremental updates. The recommended practice from Google is to do that, give a full update about every 4 updates or so. So your mileage may vary, but that is one way to drastically cut down on the amount of bandwidth that you're using and probably deliver a better experience for your end users as well. In the back end, we're going to need a bunch of features like supporting these incremental updates, or in the case of Hawkbit, they call it Delta updates. You're going to want to know things like, what was the device update history? You're going to want those progressive rollout features that we talked about that are incredibly useful. And Hawkbit is not the easiest thing to set up, so I set it to be yellow, so your mileage may vary. There is also a management UI that's very convenient for us, but it doesn't work particularly well for large fleets. It doesn't scale very well, even if the back end does, the front end doesn't. And one thing that's very challenging too about Hawkbit is that in order to specify what devices will get what payloads, you have to specify a kind of a complex decision tree. And when you're doing updates, the last thing you want to do is have something that could be easy to screw up. So just calling that out as a yellow. Okay, so in Memfault, you're thinking, you're getting a little bit cross-eyed thinking about CDNs and all this stuff. All you need to, Memfault handles all that. All you need to do is use this simple interface. We have what we call cohorts. They're different release groups, and very, very simple. You can specify the target firmware or the target operating system update or system image for a certain group. Change rollout percentages. Very hard to get wrong, which is exactly what you want when you're doing device updates. Okay, we've gone through this cycle now from debugging to updating, now monitoring. So we're getting there. So Big Corp, once they've deployed their fix, they're going to want to monitor to see if their numbers are going up. Are they going down? And what do we mean exactly by these numbers, these metrics? Metrics, we mean measurements. This could be the time that the device takes to come out of kernel suspend, or it could be the rate of battery drain. In other domains, the metrics are called analytics. That's a little bit more of a business connotation, so we tend to use the term metrics. And one of the main things that we're going to be focusing on with metrics or keeping in mind is aggregation. So taking those raw metrics and being able to aggregate them to get insights and better visibility. One of the things that we've, I think probably everybody's seen in addition to Logcat is the battery historian, this thing. Very easy to quickly spin up and analyze a bug report. But it's pretty limited. What about what happened even earlier that day, or trends in the fleet? Come to think of it, how do we even get the bug report? So really, this is a pretty specialized tool. So I would personally give it the thumbs up. Great to use, but it's only really going to give us a dashboard for a single bug report. So yeah, very, very narrowly scoped. So battery historian will be rendering the statistics that come from an API on Android called battery stats. That's great. We can just even use the battery stats API directly. This is going to give us system metrics in I think the default is a CSV format. But one caveat is that with the battery stats API, if I recall correctly, you don't get any data when the device is both plugged in and charged. So you might want to keep that in mind. Okay, so how are we going to store these metrics? Well, there are some very useful technologies that will borrow from the more the DevOps space, Prometheus and StatsD. They're different, but maybe a little bit similar from our perspective here, ones that we see people using. And these are going to be great for storing, time series data. They're, great tools. In addition to being able to use this technology in the backend, one thing I learned recently is there's now a StatsD service inside Android. It's in Android 11. I said it was not that useful because I don't know how many companies are actually using Android 11 yet, but maybe keep that in mind. And something that you often see with Prometheus is a dashboarding tool called Grafana. Similar to Prometheus, it's not really IoT focused always. So we might have to do some adaptation there, but generally Grafana and Prometheus are going to give us a really great, powerful backend metric solution. So what's missing? Well, we haven't said anything about custom metrics yet. And, the sort of metrics that we mentioned earlier that we're interested to track in our example, like, so maybe something specific to your application or what your device is doing, or like we said, the time that it's taken to come out of kernel suspend. Not all of those are going to be built into something like battery stats. We're going to have to make sure that that's there. So you might need to fill that in with an agent, and the agent is going to handle, all the other things that we mentioned before, like spooling and uploading of data, versioning, things like that. So there's quite a bit of work to do. And again, the really heavy thing that we're going to have to implement is likely a lot of data transformation and processing. We're going to be getting things like CSV files from battery stats with lots of data gaps. And on the other hand, we want to know when there's a fleet-wide regression in battery life because we just did a release. So there's a big delta there. So we're going to have to fill that in. Okay, so we took a look at high-level landscape overview of some of the technologies for metrics. What do they look like in Memfault? Here you can see one of the high-level dashboards that we have showing things like device reboots. So we could drill into, say, to see which devices are rebooting on which day due to a low battery. And we can see the list of devices that were in that state that had that behavior. And we can drill down even farther. We can take a look at the metrics on that device. We can change to any arbitrary day, take that battery historian, and we can get some battery usage information, seeing what's consuming battery, wake locks, things like that. And we can even zoom in and check out what dose mode was doing on the device. So I think that's one of the big benefits of Memfault is not only do you get all the infrastructure, but you can easily go from very high level stuff down to very low level device investigation. Okay, so that was a bit of a journey. We went from debugging, updating, monitoring, looking at the landscape of tools. So the last thing is to understand the summary of what's missing. What do we have to build? Well, fortunately, there are many green boxes, which means there are a lot of pieces that are solved for us. That's great. There are a couple yellow boxes, so some areas that might be a bit lacking. And a lot of red boxes, things that we'll need to fill in. And some of you may have done this already, like you've built an updating solution, or you have a custom system for grabbing logs or bug reports. And this could be a roadmap for how you can continue that journey and build and extend. But I'll say one thing, which is generally what we see is that the place you get to with this approach is that all these solutions are focused on one specific domain, and they give you one specific I guess way to view your devices, or one specific thing that you can do, but it's linking all the data together that really creates that cycle, that virtuous cycle, when when the tools are not separate. So contrasting that with Memfault, we start from the same places, we start with the same APIs. We provide one agent. This is our open source SDK, and it handles everything with just one integration. We can address some of those shortcomings in AOSP that we talked about with some optional patches that we provide, but we don't modify AOSP. That's something that is a design goal of ours. And we provide all the tech, the CDN, the update logic, all of that stuff, and one platform for all of these concerns, which addresses that big challenge that we talked about, so that when you are able to then see metrics about your updates, you can get logs around your crashes. Everything is linked together. And I'll also just say, Memfault also connects with all the stuff that you already have. So if you have existing analytics tools, you want to export to Jira, things like that, we do all of that. So to circle back to that very big Corporation of America example, I'll give you a real example. So they got there's one company that we spoke with that looked very much like this. Used the tools that we described, the same process that we described, had a big outage, and they had a big win from having these tools. They fixed the problem, but things weren't all rosy. Because their data was in different places from using all these different tools. First, they missed the issue at first. It was always there. They could have fixed it before there was this big multi-month partial service outage. Because there's data everywhere, they mistriaged the issue. And then second of all, when the outage happened, getting those key insights took too long because the data wasn't linked together in one tool. So, you have to do all this tedious, error-prone cross-referencing right when it's like the last thing that you have time to do. So Memfault can really help in those stressful situations. So, there's a maturity level to tools, and having something in place is critical to resolving issues and moving fast. But just getting those off-the-shelf tools it's a lot of work. There's a lot of gaps. And getting to a mature solution, one that gives you those quick insights and doesn't have data in a bunch of different services, is a huge long-term investment and opportunity cost that can take focus away from the most important thing, right? Which is like staying competitive and getting your high-quality product to market. So, but the most important thing is having something in place before your next big issue occurs. So if you're interested, you can integrate Memfault this afternoon. Many of our customers do in a day or less, and you can try it out for free. Our SDK is open source, and we have lots of documentation, things like that online. Don't take my word for it. Kartik from Logitech speaks to how we save Logitech developers time and get a better product by getting them the tools that they need to fix bugs. At DMAI, they use our OTA update solution to help them increase productivity. And the last one, I wouldn't go to market with an IoT device without Memfault in place. Love it. And actually, this is a customer that uses Memfault for microcontrollers, which leads me to my last point. So we talked about what Memfault can get you on Android, which is helping you get a faster time to market, fewer bugs. But in reality, the embedded world doesn't start and stop with Android. Android devices may be the brains of scooters that connect to microcontrollers that control the scooter hardware, or Android tablets that are used for payments that are connected to a microcontroller, secure enclave running an RTOS. So even if you don't have additional hardware or peripherals in your product line at the moment, you may in the next one. And so, Memfault is solving the problems today, but also has you covered for the future as you grow. And so what we do is we provide a common dashboard for all of your IoT devices for Android and microcontrollers, and we're already well underway with our embedded Linux offering too. So if you're interested in that, please get in touch. Okay, well, thank you very much. I hope that walkthrough of the tools landscape was useful. I'd love to hear what tools you're using or you'd like to see more discussion about. I think now we have some time for questions.
Okay, so we have a question. Can we use the Memfault UI to search for any log lines across devices?
Yes. So Memfault, like we saw, you can use Memfault to search your logs. At the moment, log search is restricted to looking at a single captured log at a time. What we do offer, we don't have an Elasticsearch type search, so like an Apache Lucene type based search. But what we do have is a custom metrics solution that we're about to launch, and that allows you to track the behavior that is happening on all of your different devices, so you can see which devices experienced, were in this particular state or had this particular system property at this given time. So it's not log search, but it's I think it solves a similar problem of being able to identify if devices are in a particular state at a particular time. Thanks for the question.
Okay, next question. Do I have to use Memfault's OTA service in order to use the kind of monitoring and debugging features?
No, you don't. One of the things I mentioned in the webinar is that we integrate with other tools, and because we talk to so many companies that are using many different solutions, they often have partial a little bit of this, a little bit of that. We make sure to integrate with whatever you have, and you can continue to use your OTA update solution if you're very tied to it and you don't want to switch over. You can use some of our services, none of our services, whatever works for you, and you can always switch over and enable and disable different services at any time.
Okay, next question. What chipsets do you support for Android?
What chipsets do we support for Android? Well, we have our maybe I'll bring in one of the other people on the call, Chris Coleman, our CTO, and give people a break from my voice. Chris, do you want to speak to the different chipsets that Memfault supports?
Sure. Yeah, so I think the question was with respect to Android itself. Like we've set the system up so that it can be dropped into different versions of ASP as generic to kind of the architecture or the Cortex-A, or ultimately what's running Android under the hood. And then on our microcontroller side, we built out support for many different architectures. So any Cortex-M you're using, any Extensa ESP32 based platform you're using, Qualcomm chipsets. So basically the stack has been set up to be pretty architecture agnostic at that level.
Great, thanks, Chris.
Yep.
Okay, next question. Can I use Memfault if I'm shipping a GMS Android device?
Yeah, absolutely, you can. We routinely test the modifications that we make to Android, which are very few, and our SDK is open source again, so you can don't take my word for it. Go check it out. But we routinely integrate our SDK into devices, run the compatibility test suite, and we have customers that are part of the Google Partnership Program, GMS, And we provide a whole variety of configuration options, like I mentioned, and are very, very concerned about things like privacy controls. So we offer a ton of configuration there. So another question, do you have the ability to have a dashboard that combines different metrics? For example, if we want to see devices that have metric 1 below X and metric 2 higher than Y. Yes, we do have the ability to create composite metrics. I think this is it's a beta feature. And just to make sure I understand the question, so yeah, so I guess this would probably map onto how we think of yeah, different what we call composite metrics. So we have two different streams of metrics, and you can apply a transformation to them. So that is something that we're working on. We have a kind of an initial support for it, and we'll be continuing to iterate on that. But that's definitely something that we're working on. Thanks.
Okay, next question. Do you support AB OTA updates?
Yeah, absolutely. Would like we mentioned earlier, would highly recommend that, and recommend doing AB updates. So we provide an SDK that you integrate once, and it will do everything from monitoring, updating to debugging, and even within that updating, we support different kinds of updates, and you have the ability to extend the SDK by adding different UI flows and things like this, and of course the ability to support both recovery system updates, update engine updates, and AB updates as well. Yep.
Do you, so the question is, are there the same OTA security vulnerabilities that other services have suffered from?
Yeah, I guess, to my knowledge, there are certainly different security vulnerabilities. One that I'm aware of that has been, was in some different security white papers, is when you have basically different cryptographic keys that are used to sign different payloads, the system image that you're sending to the device. And if any of those keys are leaked, then anyone can create software that can then be put onto the device. And if the server itself is also compromised, then you're gonna have a big problem, because anybody can be sending any software to devices, and that's my understanding of a pretty big vulnerability that has happened with some of the OTA, over-the-air update providers recently. So with Memfault, we take a fundamentally different architecture to those types of solutions. So we never have access to any of the the signing keys that you use for your firmware or your operating system, or anything. So we will deliver software that you make to the devices, but we cannot make any software that will ever run on your device. Only you can do that. And so by design, Memfault would not be vulnerable to those types of issues.
Next question. The question is, do you support mixed Cortex-M and Cortex-A use cases? Example, an AP running Android connected to an MCU.
Yeah, we do. That our support for that is getting better and better over time. So right now, the way that would work is you'd have two different projects in Memfault, one for your microcontroller and one for your application processor. But because Memfault, does have support for both, that's no problem. You could do that today. And over time, we're also working on ways to better integrate the user experience of that. So if you have a single device with peripherals, then we hope sometime soon, is that something we're actively working on, the ability to view all of the linked devices or the peripheral devices, whether they're microcontrollers or kind of irrespective of platform, you'll be able to see everything that's linked and have a sort of synchronized viewing experience. So absolutely great question, and something that we're very excited about.
Next question. Does Memfault work on Android if my device isn't connected to the internet very often?
Yeah, absolutely. So the way our SDK is set up is, first of all, it's as I've mentioned, it's very, very configurable, and that means that it can be configured in any different way. So any kind of like runtime model, if you want it to be triggered based on events that you're interested in, you can do that. If you want it to run periodically to collect data, of course, you can do that too. And like was it the first rule of Android development or something, is like when your device is offline until a successful web request is made. So we have a similar design philosophy with our SDK, so we can collect data and we'll spool that up. Doesn't matter if the device is online or not. We use the Android job scheduler API to schedule work, and then the work will just happen when the device is connected to the network of your choosing, whether it's a metered network, unmetered network. You can provide different constraints, and then the data that you're interested in will be uploaded, and we have a variety of different configuration options for how much data can be spooled up on the device as well.
Next question. Can I control what data Memfault is sending up?
Absolutely, dovetails with the previous question. So everything is configurable. I mean, first and foremost, it's an open source SDK, so I mean, you can do whatever you want. But we do absolutely try to make it as easy as possible to configure the SDK however you like. And what that means for us, as developers, we don't have to be doing more builds and sending stuff to QA just to make a settings change. So you can actually go into our web dashboard, configure the frequency at which data is collected, which data sources you want enabled, scrubbing rules, all kinds of different settings for the SDK. All the settings are there, and we take care of propagating those settings down to the device, and then the SDK will pick that up very quickly, and you can update configuration options very, very easily.
Muting accident there. Next question. Is there any impact on the device from the Memfault SDK?
Great question. So in this case, it's sort of because everything is so configurable, it's hard to give very concrete numbers. The best thing to do is just to try out our SDK and see how you feel it works. But specifically, our every behavior that our SDK takes can be configured. So you can have it so that it doesn't run at all, that it only collects certain data sources. Things like tailing logs can be enabled or disabled. Maybe you just want to get metrics from the devices. That's very lightweight. Maybe you want to only collect crashes from the Dropbox manager. That's also a very lightweight operation. We're just taking some files and storing them inside the SDK, in this case inside of an application. So these are not very intensive processes, and we don't typically see any customers having any issues with the performance of the SDK. And we do also provide solutioning. So Steve, who's been asking the questions here, you can also work with Steve and with myself and with the Memfault engineering team directly whenever you have questions about how to best configure the SDK to optimize it best for your performance, whether that's kind of having that trade-off of battery life versus the amount of data that you collect, or whether you have a different considerations. We're there to work with you every step of the way.